In this episode, we are tackling the hidden costs and carbon impact of modern delivery. My guest, Richard Savoie, co-founder and CEO of Adiona Tech, reveals why 53% of delivery costs and emissions happen in the last mile, why most commercial fleets run 40% empty, and how AI-driven supply chain management can change that. We've talked about last mile delivery optimization, sustainable logistics, and the future of intelligent route planning. I'm Vitaliy Lyoshin, and this is an Hour of Innovation podcast. Let me know your thoughts or questions in the comments, and please subscribe. It really helps more people to find this show. And now, enjoy my conversation with Richard. Welcome, Richard. Thank you for joining me today.
Thanks for having me, Vit. Very pleased to be here.
Yeah, great to have you. So why don't we start with the origin of Adiona and the original problem that you saw and were trying to solve with this company?
Well, it's interesting because it's so unexpected in the sense that my background is in engineering. And so I'm a co-founder of Adiona as well as the CEO. And previously I was designing hardware and working in manufacturing environments and things like that. And I decided I wanted to do my own venture, but I didn't really know what it was going to be. I could have stuck with hardware and medical devices and all these other things that I worked on. But I was a bit obsessed over an idea about the optimization of where people work. Now, keep in mind, this is pre-COVID. So the idea sprung from the fact that my sister had a long commute to work in a grocery store. And she would go past 3 instances of the same grocery store to get to the one that she worked at. And I always thought that there was this native inefficiency as to how people moved, not just in their cars, but also in the public transport network, just to get to jobs that they could be potentially doing closer to home. And so the initial version of Adiona's optimization engine was really intended to solve that problem. How do we optimize for service workers, people in retail, hospitality, construction, medical, hospitals and things like that? Long story short, what we built was great, but it was very difficult to integrate into HR systems and recruitment systems and things like that. So along the way, we got introduced to logistics as another realm of optimization that we didn't really know much about. Now, my co-founder is a PhD in optimization and computer science, but again, we weren't really familiar with what was happening on the ground in logistics. And what we realized is that there's a massive inefficiency at scale in supply chain that can be addressed using AI, but it requires very specialist gloves, shall we say, to get in there and tune it to solve those problems in that environment. And that's what we became obsessed with doing.
Okay. And what were some of the technical challenges in the beginning? Did you start using AI from the very beginning, or you tried something else for that?
Well, I was fortunate that my co-founder is a PhD in machine learning as well. So part of his research was in machine learning. And keep in mind, we started in 2017. We started working together. So it was before the current AI boom, but he was already well-versed and across all of the latest advancements in AI. And I was new to that. So for me, it was around really how do we use machine learning to normalize really disparate data sets across massive organizations. So if you can just imagine a big organization Coca-Cola is one of our customers. So just use them as an example. Coca-Cola has an enormous network of locations and physical premises and supply chain data that they have to use. And it's all typically housed in very different systems. So ML and AI are perfect technology to actually start to understand how all of that data flows through the systems, map the processes, normalize the data so it can all flow and talk to each other in each of the different systems. That's where we saw the initial benefit of using AI. And then, of course, since then, as the technology has advanced, as we've been able to get access to more advanced AI technology and start developing more ourselves, we just continue to find more and more use cases for it.
I see. And then how big is your team?
There's just 10 of us. We're based here in Australia, despite my accent. We're based in Sydney, and 10 physical people. And with the way that AI is advancing, we don't expect that we're going to need to hire all that many more, considering the way that the market's moving.
Yeah, with current waves of agents and everything else, it's probably good for now.
Well,
The,
we've been lucky that we built a very enterprise grade technology stack from the beginning. We were always focused on
mhm,
enterprise. So even as a small team, we knew that we needed to build something that was very scalable, very stable, very reliable, high uptime percentage, all that stuff. And because I come from a medical device background, and quality is obviously at a premium when you're putting implants in somebody's body, we were very fortunate that we built something very robust and scalable from the early days. Now it's more of a sales and marketing problem. And that's where you see AI agents really disrupting the market and the need to add more humans to the team. Obviously, that's flowing through with AI coding agents and things like that for development.
mhm.
But yeah, from a sales and marketing perspective, that's really the first place that's getting massively disrupted by these agentic AI models.
Yeah, yeah. It's unfortunate for some of the people, but I think at the end, everybody will find their place in the workforce, and at the end of the day, I think it's for good. Um, so, so for the solution that you have, is it primarily for like big customers, or you also have, not, this is probably a wrong thing to say, not big customers, but like a commercial fleets that have like tens of thousands vehicles and things like that, or you also have something like you mentioned with your sister bus systems and things like that.
Yeah, look, we do focus on enterprise, and the reason is because of the potential sustainability impact. So just to be really
I
clear,
see.
we started the business socially minded, thinking that we wanted to address social problems, not just necessarily the environment and emissions and global warming, but also just how do we make people's lives better in their work, in their
Mm-hmm.
life. And so that original idea around reducing commute times and idle time spent on a bus or in a car was still a socially minded idea in the sense that I wanted to improve my sister's life and all the other people who do that kind of work. Likewise, in supply chain, there's impact compounding that you can make when you address it at an enterprise level. And the reason is because these fleets are so inefficient. And so if you look at the average vehicle utilization of a commercial vehicle, a commercial delivery vehicle, it hovers around 60%, depending on the market and the specific vertical that you're talking about, whether it's fast moving consumer goods and food and cold chain, or is it e-commerce delivery or construction or whatever that put stuff on a truck to deliver for. 60% is
Mm-hmm.
the average utilization of that truck, meaning that most of the time it's traveling 40% empty. And if you think about the amount of miles that go onto these vehicles, because your personal car, my personal car, I won't speak for you, Vit, but you can tell me afterwards. My personal car, which is still a gasoline Mazda because I bought it 10 years ago, it sits idle 95% of the time. I'm only in it 5%
Mm-hmm.
of its life. Now, a commercial vehicle does not sit idle for very long. It's used around the clock, 3 shifts a day, hundreds of miles a day potentially being put on these commercial vehicles. So the amount of output from an emission standpoint is enormous in commercial fleets. That's why we focus
Mm-hmm.
on these big enterprises, because there's this impact compound that you can make when you want to eliminate carbon emissions.
Yeah, that makes sense. And they're so inefficient also, like there's traffic, there's like road conditions that they cannot go fast enough, right? All those, and they use diesel, which is probably the worst fuel out of all the worst fuels. So
Exactly.
yeah, so are there any inefficiencies in terms of operations that you're also solving for these organizations? Like, for
Yeah,
example, like route optimization, for example, or things like that.
yeah, that's a great question. Because the step one and efficiency one is consolidating the fleet. How do we do more work with less vehicles? And if you can
Mm-hmm.
address that, which we very often do, that's usually the first port of call in using our technology for these companies. You minimize that fleet size, or what we call right size the fleet size. How do you make it the right size for the work you're actually doing? That immediately you get cost benefit, you get financial efficiency, you get operational efficiency, and that's great. But then, of course, there's a massive flow-on effect of, in order to do that, we need to do route optimization. Route optimization is a core part. And for those in your audience who aren't really familiar with it, there's the basic idea of route optimization, which everybody knows in their life, is I need to go to 5 places. and what's the most efficient way to get to those 5 places in the right order, depending on when I need to be at each one. We call that the traveling salesperson problem, right? It's a classic problem, been researched for decades in computer science. If you go one level up and you say, okay, well, now I've got 500 locations that I need to visit. I can't do them with one vehicle, so I need to do them with a fleet. Now, how do I automatically calculate the right vehicle to go to the right stop, all within the daily constraints of time and resource availability and staffing and all these other things? So when you do that at scale, now you can solve all sorts of other operational problems in supply chain because it dovetails into the warehouse. When do you need to pick and pack all of the inventory and the Amazon orders that need to go out to then be on the loading dock to be with the right vehicle that's going to go to the right place on that route? So then you back up from the warehouse into your procurement and inventory management systems. When can I order all of the things that I need to ship out next week to make sure that they're here on time? And I'm not clogging up my time with stuff that's not going to be actually needed for another month. So optimizing the sequence of how the entire operation runs really flows backwards from when does it need to be at its final destination. You really go backwards from there.
Yeah, I think this is also a good way to optimize time that it sits on a shelf in the warehouse, for example, right? Especially for products that are like not plastic stuff or like perishable foods, for example, or frozen foods and things like that. So that could be also important for that.
Yeah, I'll give you an example. I mean, one of our customers, a big customer here in Australia, does meal kits. So for anybody who's familiar, who's gotten a box of a meal kit or for their pets or whatever, this is stuff that's refrigerated and sometimes frozen, and it needs to be really highly optimized. And so that's a perfect application of this type of technology.
Yeah. And then also, is there anything you help with optimizing for like the last mile deliveries? That's the concept there in the logistics?
Yeah, actually, Vit, I'd say about 80% of our customers are more focused on last mile. And it's simply just because last mile, if you look at it statistically, is 53% of the total cost of delivery of a product. So if you think about anything in your house right now, how it got to you, it came from raw materials. So a book on your shelf, right? A tree, unfortunately, it needed to be sacrificed to make this book, and that's okay. Books are worth that. And the paper went through a mill, and then it went to a printer, and then it got bound, and then it got sent to a warehouse where it was held in inventory, and then eventually some courier picked it up and brought it either to the store that you bought it at, the bookstore you bought it at, or directly to your house. And let's just assume you ordered it off of Amazon or something and it came directly to your house. That last segment from the distribution center or warehouse to your house is 53% of the total cost of transport of that entire chain, including the raw materials, which sounds unbelievable, but that's the level of complexity of last mile delivery. So 53% of the cost, 53% of the emissions, because that's like a linear relationship, typically, the cost and the emissions. And so that's why we focus on it, because that's where there's a lot of low-hanging fruit to both bring financial efficiency and sustainability.
Wow, that's probably why when I order something on Amazon, they have this option to like combine multiple packages in one and deliver like a day later. And it's like a benefit they provide for customers like who are environmentally conscious people and want to help, and they don't need something next day or tomorrow or like sometimes they even deliver like the same day. So if I'm not in a rush, then I will pick that option. Yeah, that's great. Yeah. Are there any, you mentioned Coca-Cola, but maybe you don't need to mention other names, but if you have a story where somebody implemented your system and they were able to save something like maybe cost or emissions, they improved the efficiency of their fleet, any story around that?
Absolutely. I mean, we just released a series of case studies with Australia Post, and for people in the U.S. and internationally, Australia Post is the biggest delivery network in Australia, and Australia is the 12th biggest economy in the world. Okay, so you can imagine, with nearly 30 million people in Australia, it's a massive organization, right? And so we started working with them last year, and what we were able to help them do is really look at that forward-looking projections around how to do things better in the field based on the historical data. And this is where AI, of course, really shines, is evaluation and analysis of historical data and how you apply that into the real world. But what's interesting about it is, and to your question earlier, it can happen in so many different ways. So for example, we talked about last mile route optimization, we talked about the sequencing of things and the cost benefit from there. But what if you're a big organization that does same or next day delivery? You compete with third-party logistics companies to do that for your customers. And you are looking at adding in a new customer, and that customer has thousands more deliveries a day. How are you going to bolt that into your network? How many vehicles are you going to need? How many of them should be full-time employees? How many of them should be overflow contractors? There's actually this ability to use our technology to simulate and model the entire delivery network that then allows you to do hypotheticals. So whether it's for that use case, like how do I price this type of delivery for a new client that wants to do delivery through my network? How do I ensure consistency of service and accurate time of arrivals? Because when you order that stuff from Amazon, right? Whether you choose same day or next day, one of the things that they're really good at is they'll give you the estimated time that it's actually going to arrive at your house. And Amazon's been very pioneering in leveraging real traffic information, real road network information, along with everything else that you need to do that. So we allow companies like Australia Post to give that same service level. And you can imagine that suddenly that competitive nature, when you're a postal organization and you're competing with FedEx and UPS and Amazon and everybody else that does delivery, that's really critical problem to solve, to modernize that stack. So they don't just save money, but they provide a better outcome at a lower cost with more predictable outcomes for their customers, track and trace the entire way. And in terms of dollars, I can't say specifically for them, but it's enormous, the amount of potential savings that they can get.
Yeah, that's great. Especially with, I imagine Australia Post is a government organization, or is it like a hybrid? Maybe it's a government. So typically, government is probably on a less efficient end from corporations. So that's very nice to see that government is actually also investing into this. So
actually, one of the cool things, and you see this with USPS in the US as well, for people that are sustainability minded. You're absolutely right. They tend to be the slowest in terms of changing and adopting new technology, except where it comes to electric vehicles, which I find really fascinating. Because USPS, Australia Post, a lot of postal organizations worldwide have actually been earlier in adopting large-scale electric vehicle delivery vehicles than a lot of other private companies. And part of the reason is because they have the insulation of government money that allows them to take some risks in capital. So there's this difference in being able to spend capital, whether it be on an EV or a sortation facility or new real estate or whatever. That's very capital intensive, right? Whereas software isn't always necessarily as capital intensive, but there's a big change disruption factor to using new processes and things. Whereas a USPS can say, look, I'm just going to swap out these diesel vans in this one limited territory for a bunch of electric vans in this territory. And because I have government backing on my capital and I can access capital more easily, I can do those experiments. And then they're adopting EV fleets at a much faster rate. So that's another thing that we work on with them and with other organizations is how do you use tools like simulation and modeling to figure out where you can actually adopt EVs at a lowest risk and for maximum return on investment. So I'm glad you brought that up, that fact that they are a government organization, because there's cons, but there's also definitely pros too.
Yeah, for sure. And I remember a funny story. A couple years ago, I was in New York visiting my friend, and he showed me Amazon's delivery truck, which was also electrical already back then. And he was like, you see, we live in like a nice city where we're trying to switch to electric and things like that. And then last year I saw one in DC as well. And I said, okay, then now, this area also catching up.
Yeah,
So
it's great
I
to see,
think,
isn't it?
yeah, Amazon is investing in this too. So,
And when's the last time you went to London, actually?
oh, I never been to London.
Oh, mate, you got to try London because when you go there, they've got a congestion zone in the city center, and it's just all electric vans. It's quite
Mm,
shocking to see, the adoption uptake in places like London. But it's great to see big cities in the U.S. starting to follow suit.
yeah, yeah. So let's talk about AI and how you leverage this technology to help you optimize routes, for example.
Well, the core of it is we can't use just AI. AI is one tool in the kit. And so
Mm-hmm,
it's a combination of the historical data, the historical patterns that we have access to, real-time data, so knowing what the road network is doing and what the traffic flow is at rush hour and things like that, and what we call constraint-based optimization. Constraint-based optimization is actually a pre-AI technology that's been around for nearly 100 years. And it involves what we call heuristics and optimality programming. And it's this, again, something that if your listeners really want to dig into it, there's a lot of information available, but it's like peeling back a layer of the matrix and realizing that there's actually mathematical ways to perform a lot of these things and to do a lot of
mm-hmm,
these optimizations. But what's interesting about it in 2025 is that most of those algorithms that were developed to do these types of optimizations, they take a really long time to execute. The algorithms are just really require a lot of computing horsepower, and that scales exponentially. So the more, just
mm-hmm,
say, for example, in your neighborhood, I've got to deliver 100 parcels today. Every time I add another parcel to that, it's an exponential increase in the amount of computation time it takes to solve it. Now,
wow,
where two technologies are really disrupting that, AI, one of them, because it can actually just help to focus the problem, manage the iterative nature of solving it, and also include all of that historical information to, again, make sure that you're solving the right problem. But it doesn't really help
mm-hmm,
necessarily with that exponential processing time. But the second one that does is quantum computing. And so we're researching how quantum computing can actually help us to parallelize a lot of the processing of that and solve it much, much faster. So these are really the key technology solutions that are critical in a business like what we do for optimization. Is big data science,
mm-hmm.
constraint-based optimization, AI, and quantum.
So does your inputs to these calculations include things like what type of vehicle it is, routes, like type of gasoline, or what goes into those calculations to kind of help automate or save cost of fuel, right? Time and emissions also, which are all your three important things or metrics, I would imagine.
Yeah, and it's also a good way of unpacking why it's taken so long for these types of technologies to be adopted. So to your question, a really key component of it is just the vehicle capacity and the size and
Mm-hmm,
weight of what you're delivering. So you can imagine that an Amazon parcel van, so Rivian makes those electric vans that you saw in New York City for Amazon. So a Rivian van has a certain payload capacity, both in terms of weight and volume. And the parcels that go into it have a weight and a volume. And so you simply need to make sure that you don't exceed the capacity of the van, but you try to stack it as full as you can, right? Now, that
mm-hmm,
dynamic changes completely depending on the type of product that you are delivering. So if you add a cold chain component, just assume it's the same problem, but now it's meal kits. Well, now you've got a time constraint on them. They can't be out on the road for more than a certain amount of time, or they'll get warm.
mm-hmm,
So you've got a time component as well. Now imagine that you also have a time component where the customer has paid extra to get it at 12 noon instead of just a wide time window from 8 a.m. to 7 p.m. They've paid extra to get it at 12 noon. Now you've got a really strict time component. Now imagine it's pallets instead of cartons, massive heavy pallets that will maximize the weight of the vehicle probably before they maximize the volume. So
mm-hmm.
all of those different data points will go into our optimization. And one thing that the industry, when we call supply chain digitization, has had to do is to digitize a lot of that data, which historically would just be on scraps of paper or spreadsheets in a warehouse. You know what I mean? So once a company has invested in digitizing all of that, then we can start to do these really clever things with that data. Even location data, like a big parcel carrier historically would have relied on the driver to know where your address is in their head. So they go to their dock and they load their van and they go out to do their deliveries and they look at all the addresses and they don't even use a map. Historically, even 20 years ago, that's the state of the art. Only in the last 20 years, 25 years, since GPS and mapping data has started to mature rapidly, then they went to saying, okay, well, now I can look at it on a map and I can help to self-optimize using my brain, to figure out where to go. And then you combine in the technology that we start to do, and now, okay, you create a route for them on the map, which is way more efficient than what they were doing in their head. And you can see that all of that data, location, weight, volume, the vehicle constraints, like you said, the fuel type, the range of the vehicle based on that fuel type, it's going to be very different range depending on whether it's a diesel vehicle or an electric vehicle. All of that information has to go into what we do.
Yeah, I can imagine. What was the most challenging thing to figure out this system? Because sounds like you're relying on customers having these digital records, keeping track of everything. Was it the most challenging, or something else maybe?
Oh, it's a tough one, Vit. I think one thing that was unexpected to me as an outsider was the priority on edge cases. If you know what I mean by an edge case, I mean something that only represents maybe 1% to 5% of the scenarios that you encounter, but to the company or the end user is so important that you have to manage and you have to handle it. And we had, again, as a startup in our early days, we had to create this balance from a technical standpoint of how much can we generalize and how can we create enormous value for these enterprise customers in a generalized way versus how much do we have to invest in focusing on edge cases. And if you look at a lot of our competitors, some of them have invested very heavily in edge cases and being super configurable and customizable and being everything to everyone. And strategically, we decided to go a different route, which was to figure out some use cases where we could be very generalized, but thereby create even more efficiency because it does that general problem so well. And then focus on the customers who are willing to, invest their time in handling that general solution and then worry about the edge cases later as like a follow-on, or still just do them manually and not worry about it being solved by the AI at the time because it was just too hard. That I'd say honestly, and this is why I bring it up, is because I think it's a cautionary tale for any innovation-minded person, and especially people who do engineering, right? It's so easy to get buried in the edge cases and follow those rabbits down the hole. But you may be limiting yourself in terms of how fast you can get on market and how quickly you can get some adoption. But the problem is customers don't necessarily know what they want. You have to be able to help them and guide them through the process of, and a lot of it is psychological. You're going to get this massive benefit from, generally changing your operations and getting this massive benefit from AI. But you will have to still struggle with these edge cases for a while. It's still just going to be an intractable problem we're going to have to work through together. And some customers are willing to do that, others are not. And in your early days as a technology company, just focus on the ones that are willing to have that conversation and get rid of the ones that are not, because it's just going to be a waste of your time. So that's both a technology and a sales challenge that we had to address from the early days.
Yeah, I think it's like going back to that Pareto 80-20 split, right? If you're running your business for a while, there are a bunch of edge cases that happen once in a while. Yes, they may be important, but if you can optimize a lot, those 80% of cases that are general, do you really need the other 20 that suck all your energy out and like add half more expenses and things like that. Maybe just like cut them out or something. That's a very interesting approach. That's great.
Yeah, well, it's interesting too because there's always the element of human disruption. And one thing that it's important for people to realize is that there's currently 450,000 manufacturing jobs in the US that are unfilled. And organizations, I think, about 60% of supply chain organizations say that they're struggling to recruit humans to do the work. And so we often will get edge case kind of conversations from people who work in a warehouse and they do routing and manually allocating jobs to drivers, and they're threatened by this type of technology because they're worried it's going to take their job. But what we love to have the conversation with them about is that maybe 80% of their job is doing this manual routing and dispatching, and 20% of it is actually solving problems. It's a driver didn't show up to work, they're sick, we need to figure out how to handle their route. A customer is upset because things didn't get delivered yesterday and they need to figure out what went wrong. Those same people actually spend a smaller amount of their time doing much higher value tasks. And so where the convergence of the technology, the AI, and the human element really shines is to have those conversations around the edge cases are actually what's most important for the human to focus on. Get rid of that 80% with AI and technology and automation, and let the human focus on the stuff that's really, it requires human communication and will for the foreseeable future. Even agentic AI will not be coming to take that job anytime in the next 10 years, I believe.
Yeah, I agree. And now everybody should be shifting to those, like only humans can do top skills and things, rather than just worrying about how to not implement this great technology and optimize a lot more things, just to save, like, I don't know, few jobs there rather than retrain people. So yeah.
Yeah, and you find a lot of these people are so skilled that there's plenty of work for them to do. They just need to shift their mindset, and they need the support of the organization. And that's where we also advocate to our customers is like, look, this will be disruptive, and you have a duty of care to your employees, especially some of whom have been working with the company for decades, to make sure that you help them transition to doing that high value work.
Right. They're going through trainings anyways, so they should just continue doing that. Yeah. What do you think are next breakthroughs in logistics with the help of AI, with the help maybe other technologies, maybe something you're working on or something you've seen in the industry?
Yeah, I think there's two big things coming. One, we've already invested heavily in, which is a closed loop feedback system to take the billions of data points that you get from the field and from the warehouse, and things that change and don't come out the way you expect, whether it's due to road blockage and weather changes out in the fields, or whether it's due to customers changing orders, which happens all the time, to then be able to predictively use AI to solve those problems. I think there's still a large benefit to gain from that. And then the second is going back to what we were just talking about with agentic AI. I think there's a massive opportunity to start to incorporate more data sources. An example of that is dynamic pricing. So I just wrote an article for our website recently about how agentic AI can potentially be used to focus on profitability. And so you can imagine for any delivery network, there's some deliveries that you do that make you money, and there's some that cost you money. Think of it like a bus network, right? Like there's some bus routes that are always busy and they're going to make the bus operator money. There's some that aren't busy, but the government mandates that you need to cover them, and they're going to lose you money, right? So there's loss leaders and those profit leaders. And so agentic AI is a really interesting opportunity to dynamically calculate who is a profit leader and who's a loss leader in your delivery network, and then optimize for that. And traditional AI and machine learning just can't do that because it's not dynamic enough. Whereas agentic AI presents an interesting opportunity. Part of the case study that I wrote about was a medical supplies company that was using a prototype of agentic AI during weather events like snowstorms to make sure that the high value and also critical care medical supplies that needed to get to a hospital at a certain time were prioritized, and everything else was deprioritized. And traditional systems and humans really struggle to do dynamic prioritization especially once the vehicle is like out on the road. It's very, very difficult to change that. Whereas I think if you extrapolate that at scale and think about how that prioritization can help both the company while not reducing the service levels for the customers, it's going to be really interesting to see how that changes things.
Yeah, that's great. I always like to hear things like that when companies doing something already, piloting something. That's always great. And yeah, I have so many ideas in my head about things like that. Even like simple, maybe not simple, but something I think about, like how quickly police can get to the crime site without like around traffic and bottlenecks or whatnot, or crash on the road or things like that, because that's important. Every second there is important. Or when I see somebody on the road blocking ambulance and can't move quickly enough and ambulance gets stuck, those type things could be potentially also optimized in real time somehow. Maybe by that time we have flying cars. I don't know. But
Well, it's a really good point, Bit, because there's a company actually here in Sydney that sells a system worldwide to cities called SCATS. And it's the system that has the inductive metal loops underneath the concrete at intersections. And so it senses that a vehicle is over it, and then it tracks the traffic flow through that intersection. And they use it to calibrate the stoplight times and things like that. But what a lot of people don't know is that it's also used in emergency situations to free up an all green light corridor for an ambulance or a police car to go. They can actually optimize the route for that. But traditionally, it's just manual. You know what I mean? It's somebody that's sitting behind an operator desk in a city control tower that says, "Oh, there's a police call. I'm going to light up green lights for that police car." Now we have the opportunity to combine this physical, you can call it like IoT technology in the real world with AI that can then automate that process.
Yeah, and then I also wonder if anything coming for other types of vehicles like airplanes or ships in the sea, because they burn a lot of fuel as well. They fly around, and ships probably pretty efficient in terms of how much they can carry, but airplanes, I'm not so sure. They definitely fast, but they're like balancing everything out, and how to optimize those could be interesting to see.
Well, you bring up a really good point, and not to, for the sake of conversation rather than contrarianism, this is one of the reasons that we focused on road transport, is that in the transport emissions spectrum, road transport is about 60%, and 60 to 65%. I think air transport is less than 10%. So just to show you, the weighted value. Now, 10% is still huge because transport is the second biggest emitter in the world. So 10% of the second biggest emission is still enormous. But yeah, it gives you like a quantum to say, yeah, there's a huge opportunity, in different areas, and they all need to be handled differently, right? Because air transport is just so more, not more regulated, but regulated in a very, very different way than road transport, right?
Yeah. Are there any bottlenecks or issues, maybe regulatory, maybe cultural, maybe some other, in adopting these technologies and more companies investing in these technologies and start using them?
Ooh, great question. Generally, in our core business, there's not a lot of regulatory issues other than things like, companies need to mandate brakes for their drivers, right? You can't have tired truck drivers out there. And so we call that chain of responsibility here in Australia, meaning that, you really do need to be conscious of that end to end, especially for gig delivery workers, right? Because if, say, you've got a gig delivery worker that works for Postmates and DoorDash and Uber Eats, and each one of those only sees the work that they're doing for them, but that person is working 16 hours straight for those three platforms. Legally, who's responsible for that person when they get into a crash? Well, obviously the person is responsible, but there's actually more and more emphasis on the companies taking more responsibility for that. It doesn't affect us too directly. But the other thing that I think is changing, you've probably been following the cyber taxi, the robotaxi and cybercab launch from Tesla in Austin. Autonomy is something we've always advocated for and focused on, because again, massive labor shortage. We need autonomy to continue to grow the economy. And what we see is this convergence of autonomous vehicles plus bipedal or other types of sidewalk last meter robotics, being able to then start to take more and more share of that delivery market. So literally a autonomous vehicle that pulls up in your neighborhood and a robot of some kind gets out and puts the parcel at your door, and isn't scared of your dog. You know what I mean? It's not particularly worried about anything, and can work 24 hours a day. That's going to be awesome. I can't wait. I think it's going to absolutely disrupt everything. But regulatory wise, there are enormous hurdles to jump through at every step of that way, and they all vary from country to country, state to state, municipality, city to city, and that I think is a 20-year horizon for things to start to evolve because of the regulatory limitations. And you mentioned drones and flying taxis. Obviously, we've been talking about those for 15 years, and it hasn't really evolved very quickly. Again, largely because of the regulatory constraints and initially battery costs, although those have come down. So it's more regulatory than anything.
Yeah, I remember Amazon was trying to do something with drone deliveries, but again, I think it sounds so sci-fi at this time, but then a couple years later, you will see them flying around, and it will be normal. That's crazy how fast things move.
If we want to put a little bet in the bottle, my actual bet is that I think we'll see autonomous sidewalk robots adopted much faster than we'll ever see delivery drones. Now, I'm happy to be wrong, but that's just my prediction. We'll see. We'll check back in 10 years and see how it's gone.
Yeah. Okay. So then I have a couple of questions, entrepreneurial type questions for you. And was there anything? What was there that you learned as an entrepreneur with your journey that you would like to share with people who may be also kind of curious and want to start something, and they want that one lesson to motivate them?
Wow, there's so many lessons, but I think the ones that are probably, again, from a Pareto principle, the most important are to simply find a problem that people are willing to pay for. The stark reality is that there's lots of problems to solve, and some of them just aren't something that people are willing to pay for. And in order to test that, you need to be really strict in the experiments that you run. Because again, when you talk to people, it's very easy for someone to say, oh yeah, that's a good problem we're solving, and my company would pay for that to be solved. But when you actually float it up the chain and try to get a check, an actual cash for that problem to be solved, it could be a very different answer. You need consensus from so many people, and they've all got different priorities. So there's no easy answer to that problem, but you need to almost think of it like a scientific method experiment where you have a hypothesis, you have a method, and then you're going to test to see what the results are without biasing yourself too much. And I had that problem in the original days too, that commute optimization thing that I talked about at the beginning. I was really passionate about solving it, but it just wasn't something that we could commercialize easily enough. And then you have to decide, okay, well, based on the evidence that you've got, is it something that people will commercialize or not? How do you go about doing it in an efficient way and running those experiments? Do you need to raise a lot of money? Do you need to use external capital? Or is it something that you can use modern AI vibe coding tools and solve, build a prototype yourself and then test if people will solve it? And that leads to number 2, lesson that I learned the hard way, is you need to invest in marketing and branding from day one. And as an engineer, it's very easy sometimes, at least my personal trap or mistake was to think that the marketing and the branding is secondary to the actual technical solution or the product, and it's not. The vast majority of the people that you need to sign off on your technology or your product are going to be non-technical. They don't really care how it works. They just care, does it deliver? And then so the marketing and branding becomes really important to position it in their mind as something that's actually going to solve their problem. So those are 2 things that I wish I believed. I know they're things that people told me in the early days, but I wish I believed them enough to be more actionable on them in the beginning.
Yeah, sometimes you need to live through those things to realize that it's actually truth.
It's easy
Yeah.
to think they don't apply to you. Oh, that's just a problem that everybody else has, but I'm special somehow. Guess what? You're not
Yeah.
special. Unless it's
Right.
your like fifth startup and you've sold, and exited out of four other startups for $100 million, then you probably do not have the instincts to know what people are going to pay for.
Yeah, yeah. It's mostly for first-time founders. If you did it multiple times, you probably know the game already. Yeah.
That's right, exactly. So in future startups, obviously this is a lesson that I'll bring to it, and this is why serial founders find it much easier to raise money.
Right. Was there any way how Adiona was used by your customers that really surprised you?
That's a great question. I can say I'll give you a little story. First of all, the simulation and modeling component of what we do wasn't by design. We built a route optimization engine and then built a user experience and web applications around it. And then our customers started using it to do all of this complex simulation and modeling, and it wasn't something that we intended. And then obviously once we were tracking that and iterating it, that became a priority for us. But what some of the outcomes that have come out of that, for instance, there was a recycling, there's a alcohol distribution company here in Australia that wanted to do better about recycling difficult to recycle things. And one of those difficult to recycle things is corks from champagne bottles and expensive wine. Very, very, you can't throw them in your municipal residential recycling bin. They'll just get thrown out anyway. And so they set up these collection stations in their stores, their physical liquor stores, to people to drop off their corks. And using our platform, one of the things that they realized is that there's a massive emissions footprint in having these little like 5 to 10 pound satchels of corks they've collected shipped back to a consolidation center, consolidated, then shipped overseas to then be recycled. And the actual emissions output from the logistics of collecting and shipping all of these corks kind of was outweighing the value of recycling them, both financially and emissions wise. And that was a really tough lesson to learn for a company who was trying to do the right thing. But I think it's one of those lessons that people have the opportunity to use solutions like ours or other solutions to really be more methodical about what is the end-to-end impact financially and sustainability wise, and then make the right decisions based on that.
Yeah, that's a great story. I'm sure there are more examples like that when something like this exists, and it's good to know that if you just want to take this loss and continue doing it, or you're gonna stop and find another way where you can make a bigger impact. Actually, yeah,
Exactly right. Like maybe there's another way that they could partner with another company and figure out a better way. But it's cool because once you have that transparency and that knowledge, you can pivot and figure out a better way.
yeah. What's next coming for you and for your customers? Maybe something exciting you building and soon will be released.
Yeah, well, we really are focusing on agentic AI and incorporating that into the products. I think that's going to be really important for our growth. And then also things like focusing on electric vehicles. That's really important to us. It always has been. We built the first electric vehicle routing solution in the logistics market. And it's been slow going, to be honest, just because obviously EV uptake has been really slow in North America. Where we're focusing on deploying that. So that's a big focus for us in the next year is helping people with their EV rollouts. Another thing that we, again, didn't anticipate, but we're being more reactionary to the market, is that the current tariff situation in the US and the way that it's impacting supply chain and logistics in the global economy has actually been something that's good for us in a way, because unfortunately a lot of companies are very worried about how it's going to impact their margins, and they need to go back to some fundamental modeling of saying, well, what's my cost to deliver all of this product in the US now, considering I'm getting hit with an X amount tariff, and that tariff isn't fixed. It might change. It could be different next month. So how do I run a set of simulations and analyses, best, worst, nominal case type experiments to figure out how to then plan for the future. And I think the companies that do that well will be much better positioned and insulated to respond to chaos and to changes in the market. And we're building solutions that are specifically focused for looking at simulating based on global supply chain variability.
Great. Yeah, that's great. All right. Well, Richard, thank you very much for your time. It was a pleasure talking to you, learning about all these cool things in logistics and what you're doing. Thank you.
Likewise, Vit. Thanks for the conversation, and it was really enjoyable.
Okay, we'll keep in touch. Talk to you later. Bye-bye.
Thanks, Vit. Bye.
Thanks for tuning into this conversation with Richard Savoie. I hope it gave you new insights into AI in supply chain management, last mile delivery optimization, and building a more sustainable logistics industry. If you know someone who's passionate about cutting costs and carbon and transportation, share this episode. It might inspire their next big move. Don't forget to subscribe and leave a quick review or comment. It really helps others discover the show. Thanks again, and I'll catch you next time on An Hour of Innovation.